kids, here we go. This is my first official video, although the videos before this you definitely need to watch to understand this, so whatever. But you better at least watch this for Monday's questions. Okay, so this is Monday's lecture on top of the video I just posted yesterday. Let me drink my water like I would normally in class. Alright, so here we go. If I would the trig functions. So definitions, the sine of theta, which is denoted sine of theta, is the y-coordinate, so sine is the y-coordinate, of the point you get to on the unit circle by walking theta units. So when you get to that pi over 4 spot or that pi over 2 spot, so theta, as we're going to learn later, is actually the angle. Okay. Right now we're calling it pi over 4 miles or 3 pi over 2 miles, which is the same as radians because they're really the angles. I'll explain that later. I already warned you that the mileage that we get to, those spots that we walk to on the circle, I'm calling them miles so we can call it a distance. It's actually angles that we're walking. Okay, that'll be explained later. So just know you walk those miles, and if I ask you for the sine, I want the y-coordinate, the y GPS coordinate. Okay. Definition, the cosine of theta, denoted COS, parentheses theta, is the x-coordinate. Okay. Now here's what I want you to know. I left a little bit of space. I think I will probably upload these notes too, so you have them. Maybe you have them, print them out while I write. I don't know, whatever you want to do. But don't get freaked out about like notation. You're going to see sine of x, cosine of t. This is just your variable. That's your input. So don't get confused. Tangent, we'll talk about tangent in a minute. Tangent of theta. That's your input. Okay? That's just your variable. So just because it might say sine of x doesn't mean sine is the x value. Sine is always the y. Cosine is always the x. This just represents your variable, the thing you are plugging into this function. It says trig functions. These are functions. So just like we have polynomials and rational functions, now we have trig functions. You plug stuff in and get stuff out. Okay? So that's your input, and then your output. This is your input, and then your output is the GPS coordinates. Okay? So you plug in the miles or the radians, and you get out the GPS coordinate. Okay, that's how we're going to do this. Alright, here we go. So I have a circle. Okay, and let's go through our unit circle. The basics we start with, so we got 0. I'll use another color, doesn't matter. I'll use pen. 0 spot, that is the 0 miles, and those GPS coordinates are 1, 0. And then you got pi over 2 miles, and those GPS coordinates are 0, 1. Pi miles. Oh, let me erase that. Oh, I gotta erase some of these spots. I done messed this up. Whoopsie. Pi over 2 miles, which is the point 0, 1. Pi over, or pi miles, which is the point negative 1, 0. And 3 pi over 2 miles, is 0, negative 1. And then 2 miles, 2 pi miles. Okay. Now I have the little approximated symbols because even though these are the exact mileages, I need you to also know the approximations. So 2 pi, remember, is about 6.28 because 2 times pi, which is about 3.14. That's where we get it from. Pi over 2 is approximately 1.57 miles. Okay. Pi is about 3.14 miles. 3 pi over 2 is about 4.71 miles. Okay. So know the exact mileage using the pi symbols, and know your approximations. We'll get into approximations later. GPS, those are GPS coordinates. Okay. Alright. So I just want to do some examples. If I said find a cosine of 3 pi over 2. That means walk 3 pi over 2 miles. Okay. Okay. So go to that famous spot and then tell me the x GPS coordinate. That's what that means. Okay. So here we go. I'm going to walk starting at 0, and you move counterclockwise. And I'm going to walk to the 3 pi over 2. So I got some energy today, and I'm going to walk around this track, and I want to go 3 pi over 2 miles. So I land here. Okay. I want to know the cosine value. So that is the x coordinate. What is the x coordinate at 3 pi over 2? It is 0. So it equals 0. That's the answer. And that's cosine of 3 pi over 2. Alright, if I did B, sine of 2 pi. Sine of 2 pi. That means I want to walk 2 pi miles and tell me the y GPS coordinate at that point. Okay. So I'm going to start at 0, and I actually have to walk 2 pi miles. I have to get there, so I need to do my exercise, walk around until I get to 2 pi miles, and I'm here. And that's back at the starting point, but that's how many miles I walked, but I want to know the y value. So the y value at this mileage point is 0. Right. Let's do another one on this guy. So if I said C, okay, sine of 5 pi. What if I wanted to go 5 pi miles? Alright, I'm getting some energy. So again, I start here, and I walked 5 pi miles. So 1 pi, 2 pi, so I gotta do more than one lap. 3 pi, 4 pi, 5 pi. This is 5 pi miles. Okay, and we talked about those evens and odds. If you know by heart your odds are over here and your evens are over here, you don't have to keep walking. You just know that you're going to land there. So sine of 5 pi, what is that sine value? It is 0. Okay. While we're at it, what's the cosine value of 5 pi? It is -1. Okay. Alright. Do another one on here. E. What if I wanted to know cosine of -4 pi? Cosine of -4 pi. This means walk 4 pi miles, but backwards. Okay. Clockwise direction. It does not mean your answer is going to be negative. It means that you are walking in the clockwise direction. And then tell me x coordinate because it's cosine. Okay, so here we go. I'm going to start here, and I'm going to walk backwards. There is -pi, -2 pi, -3 pi, -4 pi. So even those evens are still on that right side. So whether you're negative or positive for these guys, the odds are always over here. Odd whole numbers, even whole numbers for your pi guys. Alright, so what is that cosine value? That is 1. So again, it does not mean your answer is going to be negative. It means you walk in the backwards direction. Okay, so the clockwise direction. That's what that negative means. Alright, I'm going to transition into another sheet just to do a bunch more examples. But I'm sure you get get all that down. Okay. Again, I'll scan these and you can have them. I'll put these up so you have them. I'm trying to write as neat as possible. All right. So, let me give you some information. I want to try to use all my sides of my papers. Some more definitions. So here we go. And then we can do a bunch of examples. More definitions. Or more trig functions. Alright, so here's the rest of the trig functions, because I'm going to give them all to you, and then we're going to just do a bunch of examples. Alright, tangent of theta equals sine of theta over cosine of theta. So that's the y value over the x value. Okay. Secant of theta. Okay. So I'm going to write this out. Secant. Write this out. Tangent is 1 over cosine of theta. So that's the 1 over the x value. Cosecant of theta is 1 over the sine of theta. So that's 1 over the y value. So that's just the flip of cosine, the flip of sine. And last but not least, cotangent of theta. That is the flip of tangent. Okay, so it's cosine of theta over sine of theta. So that's the x value over the y value. Okay. Let me write this out. Cosecant, cotangent. Okay. So those are your other trig functions. So there are 6 trig functions. I'll write the other ones right here. Sine of theta, cosine of theta. That's the x value. That's the y value. Oh, I messed that up. That's the whoopsie. Y value, the x value. Alright, so there's 6 trig functions. Sine, cosine, tangent. Those are your 3 main ones. And then the flips of all of them. Secant, cosecant, cotangent. Okay? You gotta know all of those guys. Alright, if you're writing notes, I suggest that you write these notes as if we were in class. Okay, that's gonna help you remember more. And then you can take your own little notes or whatever. Even though I'm gonna scan these and print these, still, for your brain, I need you to write something down. Alright, now that we know that, let's recall, since I want to use all this paper because I'm a big nerd, the other trig, the other pieces of the unit circle. And then we'll do some more examples. I should probably be timing myself right now. Okay, whatever. Alright, oh, that's janky. Oh, you guys already know. If I was on the whiteboard, I'd be erasing. Okay. I'm just going to recall the other famous spots that we talked about in the other video that you should be watching. Jeez. This is why I had that other circle pre-drawn. Alright. I'm just going to draw the first quadrant. Okay. That's the easy one. You split that in half. That's pi over 4. This guy, pi over 6. And then this guy is pi over 3. Alright, and then you need to know their GPS coordinates from the other video. Pi over 6, those GPS coordinates. So if you walk pi over 6 miles and you land here, that's how many miles. That's the distance measurement. But I asked you your GPS coordinates, and you would tell me square root of 3 over 2, comma 1/2. If you walk this pi over 4 chunk, and I say, what's your GPS coordinate so I can find you? Square root of 2 over 2, comma square root of 2 over 2. And if I said, alright, now I need you to walk this pi over 3 chunk, what are your GPS coordinates? 1/2, comma square root of 3 over 2. So you gotta have those guys memorized. Okay. Now we have all those and all the other ones in the other 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. they each have some, so there's 3 more here, 3 more here, 3 more here. We'll write them down as we go, as we need them. But now you have those other GPS coordinates. So we can find the other trig functions with these guys. Okay, so I'll show you what I mean right now. Alright, water break. Alright. Bam. Yes, I have them written out. So I'm just going to do some examples. I'm going to write my examples out, and then we'll go on the unit circle and find them. Okay. So let me get my pen. I'll do black. So find. And when you do your homework and stuff, this is the work that I need to see. Okay, so when I ask you to find these trig values, I'll get the homework up tomorrow. And you can start on it, because clearly you're watching the video no later than tomorrow. I need you to show the work on unit circles. So you can either draw your own unit circles or one big unit circle. I can post a PDF of this and you can print it, or if you can draw like on your screen or whatever, pull up whatever you want to do. But I need to see work on a unit circle. Okay, you must show work. This is the work I need to see. All right, I'm going to write down a bunch of examples and then we'll go through them. Find a cosine of pi over 6. Okay. B sine of 3 pi over 4. Okay. C tangent of 5 pi over 3. Okay. D secant of 7 pi over 4. Don't worry, I'll move these all up and we'll go from there. Alright, we'll start with those, okay? So, when I say find these things, that means you gotta, this is in your head, so you think. Go on unit circle, walk the pi miles, get GPS coordinates. That's your train of thought. Okay, when you see cosine of a number, sine of a number, tangent of a number, etc. Okay. Alright, here we go. Oh, and just in case so you know, if you're drawing your circles, the bigger your circle, the more accurate circle, for approximations anyways, the better your approximation is going to be. We'll get into approximations in a little bit. I just wanted to do the famous guys first. But you want to have nice circles. Alright. Cosine of pi over 6. So that's a famous guy. There's pi over 6. Okay. And my, just for practice, I wrote 3 over 2, comma 1/2. What is my cosine value? That's the x value. Okay. So my x value, that is square root of 3 over 2. Done. I have found cosine of pi over 6. Okay. So that's why I said, get your unit circle memorized. Eventually, you don't even have to show work because you're going to have it in your head. But for your homework, I need you to show work. For your quiz next week, after the test this week, the next quiz, I need you to show work. Let me write that down. God forbid any of you not watch my video and you just print the notes. I have it written down and I said it out loud. Must show work. Alright. Next, sine of 3 pi over 4, I'll do it on the same circle. So I have 1 pi over 4, and you might not draw all this out, but I'm just memorizing. You're counting 2 pi over 4, which is pi over 2, 3 pi over 4. Okay, and again, those coordinates, pi over 4s are the easiest ones. They're the same thing, square root of 2 over 2, square root of 2 over 2, but when you get to this point, you move left on the x-axis, so that's negative, y is positive. Alright, so my sine value, that is y value, and that is square root of 2 over 2. Done. Okay. So pick off the y value, that's what you're looking for, because it's sine. Alright, tangent of 5 pi over 3. I'm going to do it on the same circle. So we have pi over 3. Label that. 2 pi over 3. 3 pi over 3, which simplifies to pi. 4 pi over 3. It's like, Sam, how do I know it's here? Because follow this pi guy. Okay. And then 5 pi over 3. Count your pi over 3's. Alright. Tangent. So let's label that xy coordinate. Pi over 3, guys, are 1/2 comma square root of 3 over 2. Get these memorized. And this green, let me remember not to use it. It's not that great, but whatever. 5 pi over 3 tangent 5, that is sine of 5 pi over 3 over cosine of 5 pi over 3. So that's the y value over the x value. Alright, here we go. The y is square root of 3 over 2 over x value is 1/2. Multiply by the flip. Square root of 3 over 2 times 2 over 1. That equals square root of 3. There is tangent of 5 pi over 3. So simplify completely, my lovely people. I'll pause. And I know you're not going to show all this work. You're probably just going to flip it in your head and go, fine, that's fine. But I at least need to see this work on the unit circle. I need to know where you got this answer from. Oh, it's because you went to this spot and did that. Like, I need something. Alright, let's do another one. Secant of 7 pi over 4. You know what? I think I just showed you guys more than I was supposed to show you. Look at my stuff. Oh no, it's everything. Secant, everything. Okay, whatever, we're good. Either way, you need to know it. Secant of 7 pi over 4. So let's go to 7 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. You know how it's easy to remember that? This is 8 pi over 4, since this is 2 pi, so it's 1 less pi over 4. Okay? Alright, 7 pi over 4. Bam. Right there. Let's write down our GPS coordinates. Square root of 2 over 2, square root of 2 over 2. Let's look at the signs. X is move right, so that's positive. Y is down, so that's negative. Alright, I want secant. So secant is, by definition, 1 over cosine, and it's 7 pi over 4. So that's 1 over the x. So that equals 1 over, what's my x value? Positive square root of 2 over 2. People mess up these values all the time. Do not lose your negatives where they're supposed to be. Multiply by the flip. That's 2 over root 2. I don't care if it's rationalized. You can leave it like that. That's totally fine. There's going to be situations that come up later that I'm going to say, hey, yeah, you should rationalize that. But as far as finding these values, like just plugging in stuff and giving me a output, I don't care. But if you did want to rationalize, this is optional. Multiply the top and bottom by that. Square root of 2 over 2 over square root of 2 over 2. That's square root of 2 root 2 over 2. That simplifies to square root of 2. So this is, either answer is fine. Stop there. Just stop. I don't need you to go any further. There's nothing wrong with it. There's only going to be a couple cases where it's nice to rationalize so you can realize what it really equals. We'll see that later when we get into equations. Okay. Alright, let's do some more examples. I can do another one on here. Let me give them a different number. A, B, C, D, E. Sine of 17 pi over 6. Oh, look at that. If you're thinking about 17 pi over 6, but Sam, there's only 12 pi over 6s. Like, in the whole unit circle, in one lap, there's only 12 pi over 6s. Alright, so we got to get to 17 pi over 6. Okay, so you can think about it a couple different ways. People do it differently. This is how I teach it. I teach it in mixed numbers. So, 17 pi over 6, that is really, let's do a mixed number. 6 goes into 17 how many times? Twice. How many are left over? 5, 6. So 17 6 is 2 and 5 6, right? Alright, so that's really, and this is all attached to a pi, so that's really 2 whole pies plus 5 pi over 6. 5/6 of a pi. 2 whole pies, 5/6 of a pi. So I need to go around the unit circle one whole time, so 2 pi's, and then another 5 pi over 6. Okay, so here we go. If I go to the unit circle, 2 pi over 6, here's 2 pi, sorry, not 2 pi over 6, 2 pi, here's 2 pi, so I'm already there. Bam, there's 2 pi. I've already done that. Now I need to go 5 pi over 6 more chunks. Okay, I'm talking in chunks. Alright, here's 1 pi over 6. Here's 2 pi over 6, which is really pi over 3. 3 pi over 6. 4 pi over 6. 5 pi over 6. Now, I'm just showing you that you went 5 pi over 6 spots. If you know this by heart, you know that if you go 2 pi, 5 pi over 6 is automatically there. You know your spots by heart. But until then, you can count out your 5 pi over 6 chunks. Okay. Alright, so you're here. Pi over 6 is square root of 3 over 2, comma 1/2. But this guy is negative. Okay. Alright. Again, let me make sure we're good. 17 pi over 6, I made that a mixed number. 2 and 5/6. So that's 2 whole pi's. That lands me there. I've already walked that fast because I know 2 pi is right there. Then I need to go 5 pi over 6 more chunks. So this is where I finally landed after I've done all of that work, all of that walking. 17 pi over 6 lands there. Okay. I'm going to write that down. 17 pi over 6 is right there. Alright, I need to know the sign value. So what's my y value? 1/2. Done. Okay. So you can make mixed numbers. There's other ways you can do it. But you can lap that circle as many times as you need to. Okay. Alright, let's do some more examples. A, B, C, D, E, F. What do I got going here? Cosecant of negative 17 pi over 3. And I think because this video is getting lengthy, I'm going to do the approximations tomorrow. You write down a note for me. And I'm still going to put that up tomorrow, but I can cover it in Tuesday's office hours. Alright, cosecant of negative 17 pi over 3. Let me get a different color for that. Again, I'm going to make this a mixed number. So 17 pi over 3, ignore the negative for right now. 3 goes into 17 how many times? That is 5 times. So 5 whole pi's. And how many left over? 2/3. So 17 over 3 is 5 and 2/3. Okay. So I need to walk around 5 pi times and then 2 pi over 3. Okay, 2 pi over 3. But it's negative, and negative means to walk backwards. It does not necessarily mean your answer is going to be negative. Okay, so here we go. Let's walk. Alright, 5 pi miles. 1, 2, 3, 4, 5. You should already know that 5 pi is right there. We have walked 5 pi. But what's wrong with that? We didn't walk backwards. But it's still there, so let's walk backwards like we were supposed to. In this direction. Okay, backwards. So that's negative 5 pi. Still the same spot, but you don't want to screw up your direction. Now we need to go, okay, so it's negative, and that guy's a negative. Negative 2 pi over 3 chunks. Okay, so that's why I've been talking in chunks. Now I need to go, negative means backwards, but 2 pi over 3 chunks. Alright, so if I'm here, I need to walk 2 pi over 3 chunks. Not to the 2 pi over 3 spot, so be careful. I'm not walking to this spot. This is 2 pi over 3 right here. I need to walk 2 pi over 3 chunks. Okay? So it's a measurement. It's a distance. So that's how I want you to think. So if I'm here, so I did 1, 2, 3, 4, negative 5 piles, and I landed here. And now I need to do 2 pi over 3 chunks. So this is a pi over 3 chunk. And then that's a, oh crap. Guys, I did pi over 4. Where's my, I was like, man, why does that look weird? Thankfully I have whiteout. This is a pi over 3 chunk. 1 pi over 3 chunk. There's 2 pi over 3 chunks. Okay, so let me do it again. 1, 2, 3, 4, negative 5 pi miles. I still need to go another 2 pi over 3 miles. There's 1 pi over 3 right here. 2 pi over 3 chunks. That's 1/3, 2/3. That's what I wanted to do from this spot. Okay? So this is negative 17 pi over 3. This is the work on your homework, on your quiz that I would need to see. I need to know how you got that answer. Okay? So cosecant is 1 over sine of negative 17 pi over 3, which is 1 over the y. That's 1 over, what's my GPS coordinates there? Pi over, that's the pi over 3 spot, the original pi over 3 spot. 1/2, comma, square root of 3 over 2. Y value is square root of 3 over 2. Multiply by the flip, 2 over square root of 3. There's cosecant of negative 17 pi over 3. Practice, practice, practice. That's all it takes is practice. Knowing your spots, famous spots, and practice them. Okay, you gotta practice walking around this unit circle. Alright, A, B, C, D, E, F, G. Alright, I'm gonna end this video soon, but I want you to do this on your own, and I'll give you like a minute before I write, and then see how you do. So cosecant, let's see, we'll do cotangent. Cotangent of negative 11 pi over 2. Cotangent of negative 11 pi over 2. And then H cosine of 81 pi over 4. Do those two. Cotangent of negative 11 pi over 2 and cosine of 81 pi over 4. Do those, guys. I'll give you, I have to time, a minute and a half. I'll give you a minute. I feel like I should play some background music while I let you work on that. Instead, you're going to hear me ruffling stuff around. I thought about telling jokes. I'm going to have to start looking up some jokes. Get these videos to be lively. If there's any issues with any of these videos, sound, quality, picture, anything, please, please, please let me know. I greatly appreciate that. I'm timing you. Alright, here we go. Cotangent of negative 11 pi over 2. So that is 11 over 2 pi, so that is 2 goes into 11 times 5 times, so 5 whole pi's plus pi over 2 plus a half a pi. Okay, and this is negative, so we're going to walk backwards. Okay. So these are negative. Here we go. 1, 2, 3, 4, negative 5 pi is here, so I'm here, but I'm not staying there. I have to go another pi over 2 chunk. Pi over 2 chunk. This is a pi over 2 chunk, okay? So from here, what's a pi over 2 chunk? Right here. So I'm landing here. So I'm at the original pi over 2. This is actually originally pi over 2. But this chunk, this distance that I have to walk, that's how big that arc is. Okay, that's the measurement of that piece of arc. That's the chunk I have to continue to walk. Okay, so I did 5 of them and then a half of them. Alright, so that's pi over 2, which is actually turned out to be negative 11 pi over 2. It's the same spot. My GPS coordinates there are 0, 1. And cotangent is cosine of negative 11 pi over 2 over sine of a negative 11 pi over 2. So cosine is 0, sine is 1. What's that equal? 0. There you go. I hate not having you guys to ask questions, like, it's irking my soul. Alright, cosine of 81 pi over 4. 81 pi over 4, what's that simplify to? So that is 4 goes into 81 how many times? 20 times, 20 pi, okay, plus pi over 4. 81 over 4 is 20 and 1/4. 81 is 20 and 1/4. So that's 20 whole pies and a pi over 4 guy. 1 pi over 4. Alright, so if I walk counterclockwise, 1, 2, 3, 4, 5, 6, there's 20 pi. I've done that. I've lapped it 10 times. I got 20 pi. Plus another pi over 4 chunk. How big is a pi over 4 chunk? It's this big. Okay? That's my pi over 4 chunk. If I wanted to do 3 pi over 4, so I say I had 3 pi over 4, I would do 1 chunk, 2 chunks, 3 chunks. Okay, it would be there. Whatever. But there's my last 1/4 of a chunk. So 81 pi over 4 is right there. What are my GPS coordinates at that famous spot? Square root of 2 over 2, square root of 2 over 2. So my cosine value is my x value. Square root of 2 over 2 is it. Okay. So I break them up into mixed numbers. You can do it different ways. It's up to you. Alright. Questions, comments, concerns, no complaints. I will go and scan this for the rest of my notes so you guys have it. And if you can use it. Alright, let me pause this.